Okay, good morning, chemistry. We are going to start Lewis structures today. I know that I'm going to give you a lot of information in this video, so this is how we're going to handle this. You need to watch the video, watch the instructions. I'm going to take you through how to do it. You have an assignment. I want you to do that assignment to the best of your ability based off the video instructions today. Ones you struggle with or questions that you have can be answered tomorrow during the Zoom meeting. Okay. I need you to submit the assignment, though. That's how you get counted as present. So do this assignment to the best of your ability today, Wednesday, and submit it so that you get counted present. I will let you come on to the Zoom on Thursday, ask questions about the previous day's assignment, and you will be able to resubmit it if you want to. If you felt good about your first one, you felt like you understood it and you don't need to resubmit it, I will take the first one. If you had a lot of questions and you feel like you ended up changing a lot of stuff, you can resubmit, and I would obviously grade the second one. Now, here's the thing with these Lewis structures. They need to be drawn. There's just no way to do them on a Google Doc that I can think of. So what you're going to have to do is the worksheet that I give you, I don't need you to print it out or anything like that. You can just on any white piece of paper, just do each Lewis structure on just a clean white sheet of paper, take a picture of it and email it to me. And that's how you're going to submit your work. I just make sure that you complete it all to get counted as present. If you struggle with it, come on to the Zoom tomorrow and I will go over some things with you. I will show you some things that will help you, and then you can resubmit. So I just want to know, everyone, you have that option. But even if you're struggling, you need to do this assignment to the best of your ability today, and then we will talk about it and answer questions tomorrow also. All right, so let's get started. Okay, so here are our formulas, and you guys took the notes for these on November the 12th and 13th. There was no audio with those. They were just, you wrote down everything. You needed all that information. A lot of that information I will be talking about now. So if you wanted to get those notes out, they could definitely be helpful. These exact examples aren't in those notes, but you could have written down the examples from the notes. Okay. If for some reason you don't have them or you weren't here, they are still on Google Classroom. So feel free to go back and find those notes and write them down, because you will need them regardless. All right. So the first thing you do when you do Lewis structures is you count the number of valence electrons. All right. So this is how this works. I have one carbon atom. So I'm going to say, okay, I've got one carbon atom times, and then this is going to be the number of valence electrons. So for carbon, you need to look on your periodic table. Carbon's right here. Now remember, this is how we count valence electrons. This group has one. Okay, hang on, let me change this to the brush. All right, this group has one. This group has two. This group has 3, 4, 5, 6, 7, and 8 valence electrons. All right, so for carbon, it has 4. Remind you how to count those, okay? So I've got one carbon atom and it has 4 valence electrons. 1 times 4 is 4. All right, I have 4 hydrogen atoms to start with, okay? So I've got 4 hydrogen to start with times hydrogen's valence electrons. So if you look, hydrogen is in that first row right there. Okay, that means it has 1. Okay, so times 1 valence electrons. So that's where these numbers are coming from, okay? And then what you do is you add it together to get your total. So 4 plus 4 is 8. Do this step first. I'm going to show you how this is important in a second. So do this step first. I feel like regardless of how these Lewis structures turn out for today's assignment, everybody should be able to count up the valence electrons in each formula. It's very doable, okay? So everybody should at least be able to do this step correctly on your work today, all right? All right, the next step is to arrange this formula, okay, into its skeletal structure. So the single atom goes first, or goes in the middle. Sorry, it goes in the middle. Carbon goes in the middle a lot because it can take a lot of bonds. So anytime you see carbon, you just put that guy in the middle and start working out around him, all right? So I've got my carbon in the middle, and I've got these 4, see there's 4 of them, that's what that means, 4 hydrogen atoms. So these lines represent 2 electrons each, okay? Now, I'll explain why I'm doing what I'm doing. I've got 4 hydrogens, so I'm putting 4 hydrogens around this carbon, okay? These lines represent 2 electrons. It's bonded. They're holding these 2 together. These are holding these together. These are these together. And this represents 2 total electrons. These are bonded electrons, okay? Okay. So what you're trying to do is you're making sure these atoms are bonding in order to have 8 valence electrons, most of them, okay? There are exceptions, and we will go over those in a minute, but most of these bond with the purpose of getting 8 valence electrons, or getting, sorry, not valence, they're getting 8 total electrons. So for instance, look at our carbon here. After we've placed these hydrogens around him, he now has 1, 2, remember these stand for 2 electrons, okay? He now has 1, 2, 3, 4, 5, 6, 7, 8. He is happy. Okay, that's the octet rule that was in your notes. They want 8 to be happy. Carbon has 8. He's happy. Now, the hydrogens don't have 8, right? Like this hydrogen, he's just got this one line attached to him, so he only has 2. But that's a perfect time to talk about this. In your notes, you wrote down exceptions, okay? But I'm going to write this here, and if for some reason it's not in your notes, go ahead and write it down now, okay? Group 1, that's this group right here, okay? Group 1, they only want 2 electrons to be happy. That E stands for electrons, okay? They only want 2. Now listen, don't get confused. They start with 1 valence electron, right? When you're counting valence electrons. But in order to be happy, the octet rule says that most want 8, and they do. But group 1 only needs 2 to be happy. They're an exception, okay? Group 2, that's this group right here, okay? They need 4 to be happy, okay? They try to obtain 4 through bonding to be happy, all right? Not 8, 4. And then group 3, that's these guys right here. They are happy with 6. So those are exceptions, all right? All other ones, so basically I'm not going to draw on this, but this whole area right here, these guys, all others, and this is the octet rule, and I know I've repeated it a lot, but it really is what this is all about. All others want 8. That's the magic number, okay? The octet rule. Okay? All right, so knowing that, so having this information, we can go back to our example here and see that's why these hydrogens are already happy with just this one bond right here, because they only want 2, okay? They're in group 1. You see them right there. They're in group 1, which means they only need 2 to be happy. So that one line does it for them. They don't need anything else, okay? All right, let's look at an example where they do need more. So here's our CF4. Okay, again, let's do this. This is a new problem. Let's do this step first, counting valence electrons. We've got one carbon atom. See, just one, there's nothing there. It has 4 valence electrons. I showed you how to look that up, which is 4. All right, I have 4 fluorine atoms. Now look, we haven't done fluorine, so let's go look. Fluorine is here, okay? He's got 7 valence electrons. This is what you need this part for. Okay, so he's got 7. Okay, 4 times 7. The total, I'm running out of room, is 32. All right, so we're trying to get 32. Now, let me go back up here to one that we completed, and let me tell you why this number is important. There wasn't much to do with this first one because the numbers just came out perfectly. But look, this number, 8, has to match the total electrons in your Lewis structure. So if you look at this first Lewis structure we did, it has 1, 2, 3, 4, 5, 6, 7, 8. It matches this number right here. Okay, so your total has to match this number. That's going to come into play more with this one. So that's what I wanted to point that out. All right, so step 1 is done. You all should be able to do step 1 for all your problems, guys. And really, I feel like for most of them, you also should be able to draw the skeletal structure, which is just your single atom in the middle with your other ones around it. So we have 4 fluorines. I'm going to put them all around the C. 4 fluorines. Okay. And here's the thing with fluorine. He's not happy with just these 2. Fluorine is in the 7th group. He is not an exception, and he needs 8 electrons to be happy. Hydrogen only needed 2, so that was it for him. We didn't do anything else up here. But fluorine needs 8. So this is what we do when these outer atoms need more. We add them, but they have to be added in pairs. Be very careful, okay? They're called lone pairs, okay? And just kind of like with our dot structures we did, we add lone pairs. They have to be, see, 2, 2. They have to be added in pairs around the sides, just like our dot structures we did earlier. So look at this fluorine. He now has 8. He's got these 2 that he's sharing, 1, 2. And then he's got these, 3, 4, 5, 6, 7, 8. Fluorine is happy. Those are called lone pairs. You need to do that for all fluorines. Okay. Remember, these have to be added in pairs. They have to be on either side. Another thing, this number should always be even because these are always even, okay? They go in pairs, either a bonded pair or a lone pair, either way. Then the last step, after everybody's happy, so I check and I make sure everybody has 8. Carbon has 8. All the fluorines have 8. That means everybody is happy. Then I look at this number, 32. When I count all of these, it has to equal 32. And it does. Okay, I mean, feel free to count, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Those count as 2. 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. They equal each other. Okay? All right, let's look at this guy. We have 2 oxygen. So we look up oxygen. He's right here. He's got 6 valence electrons. Okay, so times 6, 12 total is what we're shooting for. So I'm just going to, there's no central atom with this one, so this one's a little different. But you just draw 2 oxygens, so that's what I did, and connect them with 1 bond, and then that's where you start. All right? All right, so oxygen is not an exception. It wants 8 valence electrons. So I'm going to go ahead with those lone pairs I told you about, and I'm going to give it 8. Now, this is what you do if you do all of this correctly. Now, look, they're both happy. They both have 8, right? So that part's taken care of. The problem is that whenever I add these up, it doesn't equal 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 equals 14. All right, this is what you do if your number, after you've made everybody happy, is too high, this is how you get it down. This is called a single bond. It's one line, it's a single bond. If your number's too high, let me switch to the eraser, you are going to remove 2 off of this one, remove 2 off of this one, okay? And make them share instead. And that is called a double bond. These 2 lines are a double bond. Okay, now whenever I add these up, it does equal 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. They equal each other. That's called a double bond. You can also make triple bonds if you need to. Okay, so if this number was 10 instead of 12, I would then erase these and these. You erase 2 off of each one, and then you draw 1 line in between. So they're sharing instead of having 2 of their own. Okay? All right. Last one for these examples. We've got let's add up these first. I'm skipping a step. Okay, we've got 1 boron. So 1 boron, and check its valence electrons. Boron's here. He's got 3 valence electrons. Okay. So 1 times 3 equals 3. I've got 3 fluorines. Remember, fluorine was over here too. He had 7 valence electrons. F has 7. 21. Okay, so our total is 24. I'm going to put my single atom in the middle. I'm going to put 3 fluorines around him. So 1, 2, 3. Now, fluorines need 8 to be happy. They've only got 2 right now, so that's not going to work. It worked for our hydrogen. It'll always work for hydrogen, but it doesn't work for fluorine. So I'm going to go ahead and use lone pairs to give them their 8. Now here's the thing with boron. Boron is an exception. Look where he is. He's here in group 3. Remember, group 3 only needs 6, not 8. So he's actually okay with just having 1, 2, 3, 4, 5, 6. He's okay with just that because he's an exception. But let me tell you though, if fluorine had not been an exception, let's say there was an N in the middle, a nitrogen in the middle instead, then you would need to add 2 lone pairs up here like this in order to make them happy. And then if you needed to double or triple, you could, but be aware that the only reason that boron does not have those up there to make him have 8 is because he's an exception. Okay, you can add lone pairs up here if you need to make this central atom have 8. Okay, and then you count all these up, it equals 24. You got to check that. Everybody has to be happy and it has to equal your number. Okay. I have one more thing that I need to show you, and it's the polyatomic ions. I didn't leave room for it, so what I'm going to do is just real quickly make a spot here because it's basically the same. There's a very small difference. And there's a few more things that we're not really getting into right now that we can wait until you come back to get into. If I can just get you started on these, that will be good. So this is just the very basics. Okay, so if you have a polyatomic ion, all right, so let's do carbonate, right? He has a 2- charge. First of all, I know it's a polyatomic ion because it has a charge right here, and see, none of these do. No charge, right? If it has a charge, you know it's a polyatomic ion. So this is how it changes these, all right? You start out the same way. I've got 1 carbon. Carbon has 4 valence electrons, 4. I've got 3 oxygens. Oxygen has 6, 18, okay? 22. Now, for the charge, if it's a negative charge, you add extra electrons for each negative. So this one has -2, so I would do the opposite. I would add 2 more, okay, which makes that 24. If this was a positive charge, which there's only one that has a positive charge, and it's ammonium. So if ammonium's plus 1 charge, you would subtract 1 instead for the plus. But you basically do the opposite. So if it's -2, you add 2. If it's -1, you add 1. Okay, so that's how that makes these just a little bit different from these other ones that had no charges. Okay, and then after that, you basically do them the same. You put your single atom in the middle, which is carbon. I'll put my 3 oxygens out here because there's only 3 of them, right? I'm going to make my oxygen happy with lone pairs. Okay, this time carbon, remember boron, he didn't need any more. He was happy with 6. Carbon is not an exception. He needs 8, and right now he only has 6, so that's not okay. What I'm going to do is I'm going to add 2 up here. Make them happy with lone pairs first. It will be easier, I promise, okay? Now, everybody's happy with their lone pairs, but we have a problem. Kind of like with this one up here, my number doesn't equal. If I count all of these, it equals 26. Feel free to count so that you're practicing with me. That's going to equal 26. That's too many. It's supposed to equal 24. So we're going to do what I've told you to do before. We are going to remove, and it does not matter which oxygen you pick to do this. It could be these 2, it could be these 2, or these 2. Any of them work. I'm going to remove these, and I'm going to remove these, and I'm going to add a line instead. There we go. Now look, carbon is still happy. He's still got 1, 2, 3, 4, because these count as 2, right? He's still got 1, 2, 3, 4, 5, 6, 7, 8. He still has 8. This one still has 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay? Except now our numbers equal. That's how you get your numbers down if they don't equal. You double or even triple bond. Okay? Here's the last thing on a polyatomic ion, though. If it's got that charge, the last thing you got to do to it is put it in brackets. You know, these brackets aren't very pretty. Put it in brackets like this, and then put the charge, which was -2, right up here, out to the side. It really should kind of be to the side, but I'm just running out of room, but that'll be fine. Okay, so that's the last thing you do differently, only for polyatomic ions, and you know it's one if it has this charge right here. Okay. All right, you guys should be ready to work on your worksheet now. Like I said, try to work every problem, do it to the best of your ability. If you still have questions, jump on Zoom, ask your questions. If you would like to resubmit it, you can. If you're good with your first one, then that's fine too. All right, hope you guys have a good day.